We're going to learn about piecewise functions and their graphs. In the first example, we are given the function and we're going to graph it. And in the second example, we will be finding the function given the graph. I've written 5 steps in here. So the first step is identify the x value of each breakpoint. We notice that our particular function in here in this example is broken into 3 pieces. One occurs when x is less than or equal to -4. Another one occurs when x is between 0 and 3. I call these our breakpoints. And another one when x is greater than 3. So we've identified our breakpoints. We're going to plug in each of these breakpoints into the corresponding function. That's step 2. So we plug in -4 into the -3x. So -4 times -3. We plug in -4 in place of x. So we get 12. Then we plug in 0 in the second piece. So when you plug in 0 for x, you just get 0. And we plug in 3 into the second piece as well. We get 3. Then we're going to plug in 3 into the third piece, and we get 8. This third piece is just a horizontal line because y, which is f of x, is always 8. So we're done with step 2. Step 3, determine whether each point is solid or open. And the way that's determined is based on whether we have an equal sign or not. So notice in here that x is less than, let me just erase this. Okay, so in here x is less than or equal to -4. The emphasis on the equal to. So at -412, that's going to be a solid point, solid dot. In the second piece, x is greater than 0, not greater than or equal to. So that's going to be open because there's no equal to. In this piece, again, there's an equal to. X is less than or equal to 3. So that's going to be solid. And in the final piece, it's just greater than. So that's going to be open. There's no equal. We're done with step 3. Step 4, make a table of values and pick another x value in each region. Okay, so we're going to plug in, for example, a number less than -4. So say -5 in the corresponding region. So -3 times -5, and we get 15. That's also going to be a solid dot because it qualifies as less than or equal to -4. In the middle segment, in the middle piece of this function, we don't need to pick a point because in order to graph a line, we just need 2 points. And in this region, we already have 2 points. We have x equals 0 and x equals 3. So we already got our 2 points. So now we're going to pick one for the third region. So we need a point greater than 3. So let's say 4. And there's nothing to plug in. We just get 8. And that's going to be solid. And we already knew it's a horizontal line anyway, so we didn't really need another point, but it doesn't hurt. So we're done with step 4. Now we're just gonna, we've already determined how many pieces we have. We have 3 pieces. They're all lines. The first piece is a ray. It has one endpoint and it goes on forever. The second piece is a segment. It has 2 endpoints, and the third piece is also a ray, and it's a horizontal line. So we're going to plot our points. -412, -412, that's a solid point. negative 5, 15. That's solid. And we draw the arrow. It goes on forever when x is less than negative 4. Second segment, 0, 0. That's open as we discussed. 3, 3. That's solid. We connect. There's also something else that we could have checked. The first piece should have a slope of negative 3. So that means from one point we come down 3, 1, 2, 3, and over 1. So rise over run, and that gave us a negative 3 slope, just to verify. The second piece has a slope of 1 because of this 1x over here. So up 1 over 1, and that verifies, or up 3 over 3, which reduces to 1. Our third piece, 3, 8, and that's open. And as we said, it's a horizontal line, or you could do 4, 8 as another point, connect them, and we are good to go. That is how you graph those. Now let's see what if they have given us the graph and they want the function. So we're going to identify the x values of the breakpoints. So we have one breakpoint here at negative 5. That's right here when x is negative 5. So we're going to write, the name of the function is g of x. So g of x equals, and we're going to say if x is less than, not equal because it's open, less than negative 5. So this is open right here. Now we're going to do this piece. That occurs when x is, if x is between, so greater than or equal to 0 and less than or equal to, let's see what the x value is here, that's 3. Both of those are solid points, so we're going to put the equal signs. And then finally, the last one, that occurs if x is greater than 7, and it just goes on forever. So if x is greater than 7. Step 2, find the equation of each piece. Now notice our first piece is a horizontal line. That's just going to be y equals to some constant. That constant being the y value, which in this case is negative 9. So we're not going to write y equals because g of x means y, and it's already been written, g of x equals. So we're just going to write negative 9. Second piece, we need to write the equation in y equals mx plus b form. We have our y-intercept, that's 4, that's our b. And our slope, we're going to count, rise over run. We rise 2, we run 2. 2 over 2 is 1. So 1x, or just x. Once again, we don't need to write y equals because g of x equals has already been written. Third part, this line, if you extend it using the same slope, it's going to cross at negative 3. So I suggest you get a ruler, or you count using the rise over run that has already occurred here, which is rise 1 and run 1, or rise 2 and run 2, to get from one point to another. 2 over 2 is 1. So the slope is 1, and if you keep going, it'll hit the y-axis at negative 3. So that's the y-intercept. I hope this was helpful. Practice, practice. That's the best way to learn. Thank you.